Great, and you can see my slides. Okay, great. Okay, so we are very honored to be here, and what we are going to talk today is about data and data studies, which both of us has been studying for quite some time. In some way, well, actually, it goes to back to our PhD studies all the way back there. So I'll skip the further introductions because DC already introduced that. So let's just go to the wrong window activated. Now go to the agenda of our talk for today. So we will first talk briefly I will talk about why study data, and I will also briefly define what do we mean by the study of data, to be clear. Then Marta will talk about what are data and what are digital data, which in some ways may sound strange because we all use data very naturally, but actually when we start looking into it, it turns out to be quite a bit more complicated phenomenon than one might initially think. And then finally, I will briefly describe the emerging field of data studies, and then we have Q&A. We will try to make this in, say, 45 minutes, so that we are now at 9:15, so we should be done by 10. And then we have Q&A. If you have very pressing clarificatory questions, please you can interrupt, but I think the major discussion we might want to save for the end of this session. But if there is really something that you need to needs burning clarification, then feel free to ask. So that's the plan for today. So let's then start. So why study data? And before this, what do we mean by study of data? When I say study of data, we of course all use data for our empirical analysis, but that's not what we mean by the study of data. By study of data, we mean research that takes the data as a phenomenon from some angle as its object of study. And this will become obviously clear as we proceed through the presentation. So now, why is this important? To put it very simply, as long as we have computational systems, we will have data, and data is the element that thank you, TC. Is the element that connects any algorithmic system, information system to the world of humans, or so to speak, the real world. Because the algorithms, AI, computational processes don't work in a material, corporeal, physical world, but they work in the world of data, and then the data connects them to the whatever human affairs they are processing. So, and even if data may not be always the most trendy topic, it won't go away as long as we have computational systems. It's not going to go the way of metaverse, for instance, or these buzzwords. So in that sense, it's a safe topic, and also it's an exciting topic because it's difficult. Data is difficult to study because it's at the same time data is at the same time computational entity and a human semantic entity, meaningful entity. And historically, different disciplines are good at studying computational things or meanings, human things, but that overlap in my Venn diagram is typically difficult to study because you need to approach it from different perspectives. So, and of course, what makes the study of data exciting now is that it's not only that there is so much more data available, for instance, I'm using, just to give you an example, if you haven't heard about it, there is a website called what's called Common Crawl. This is a California nonprofit company that scrapes the whole internet every couple of months. So it's a mind-boggling amount of content. And not only that, it kind of opens a whole treasure trove of potential research topics. So there is a lot more data available for us. But we also have a technology called generative AI that potentially turns everything into training data. This is one of the key training data sets that they use to train the original ChatGPT. And so we have basically a technology that has kind of never-ending hunger for data. So this brings up whole new kinds of issues to study in the future. One being that we are actually running out of human-generated training data, which is a fascinating claim. And why it matters is that the improvements in the large language models has been largely driven by our ability to shovel more and more training data into these systems. But there are some predictions that this path is going to be kind of come to an end pretty soon. And where do we then go for more training data? Of course, one way is to one field that's actively studied and actually very interesting. There are interesting research emerging there. Is the field of is the topic of synthetic data, basically data that's not generated directly out of empirical observations, but through, for instance, some algorithmic processes. But what it also means is that we governments and companies are going to look for new places to hoard training data. And related to this, we live our whole life within the radius of high fidelity microphone and cameras. So basically, what if we could keep all these microphones and cameras that we have in our environment recording all the time, everything? Now, I'm not sure if we want such a world, but I'm saying this to kind of as a sort of thought experiment, that in some ways we tend to think that our world has already become very datafied. But in some ways we may have not seen even this, we may have only seen the beginning of the datafication of society and what happens around us. Again, I'm not advocating that this is the future where we necessarily want to kind of mindlessly go, but there are attempts. There is massive corporate and financial interest, and also massive national security interests to record more and more data from our everyday lives. And I would say that for instance, the next big breakthrough category of gadgets is going to be the smart glasses. My wife, who is not particularly excited about technology, she has 2 pairs of Meta Ray-Ban glasses because she so loves to kind of take pictures wherever we go. For instance, we went to Carnegie Hall for a concert where you are not allowed to take your pictures with your mobile phone, but she had her glasses and nobody can stop her taking pictures with her Meta glasses. Again, the privacy implications are probably going to be massive. But again, all I'm saying is that because we have all these cameras and microphones around us, somebody will try to come up with tools to use those to generate more training data. So, but yet, still, we need to keep in mind that however much and however detailed data we have, all data are wrong in some ways, but some may be useful, this is, of course, the paraphrasing the old saying, all models are wrong, but some are useful. I thought that I was the smart guy to kind of came up with this paraphrasing, but then I found a paper by some statisticians who had already used this. So I put the reference there so that I'm not claiming the fame. But my point is that whatever we however detailed way we turn the world into data, it's never the world. It's always some kind of abstraction that it's in something is left out, something is emphasized, and somebody also decides how our world is being turned into data. Just to give you an example, if I asked, I think from the Grok AI kind of who is Aleksi Aaltonen, and it gives Aleksi Aaltonen is fairly common Finnish name, and I'm definitely not the most important Aleksi Aaltonen in Finland, but because I have done a little bit of personal search engine optimization, my data is probably well represented in the training data set, so I came up there on top, or maybe it just knew that it was being kind to me. So what I'm saying is that the more and more our world is driven through database systems, the more and more it will matter how that kind of that data represents what out there. So just to summarize, and I think I'm just spot on time, so Marta, I will turn to you very soon. So my argument is that the study of data is more relevant than ever because the data mediates between the algorithmic systems, organizations, and their environment more and more. Basically, AI turns everything into potential training data. Yet we have currently tapped just a fraction of potential training data sources. We will see a lot more of this happening in the future. Data is never a perfect representation of reality, but more and more it becomes the factual reality. What matters is what's in the data. Also, data and their production and use are not neutral, but they touch upon the very most intimate and sensitive issues of our lives. We have studied, and Marta is particularly expert on personal data, which is a very fascinating theme in this sense. So that's basically a short introduction to why study data. And I turn to Marta, who will talk about what are data then.
Thank you very much, Aleksi, for setting the scene and introducing us to this topic and also showing us the stakes for why it's important for us to study this and pay attention to this topic. What I would like to do is to start by seeing how we got there. And what I would like to invite you to do with me is to go on this more, if you'd like, historical journey and see how it all started, if you'd like. And if we roll time back and look at the first instances of data that we have, we can, for now, refer to it as physical data. So surely we've had instances of physical data for more than centuries, for entire millennia. And an example in here are clay tokens that Christina Lyman, Yanis Kalinikos, for example, talk about in their work and in their book. And these clay tokens were some of the first instances of data that we had. And they have some interesting characteristics that we note. They are recorded when the physical form is created. When you take a clay tablet and you make an incision or an inscription on it, that's when you record something as data. So the physicality and the data content are one in this sense, right? And if you want to change that kind of a data, you need to destroy your clay token, right? There is no other way because it has dried. So now it's that thing. So you have to destroy it or you have to remold it into a different piece of data. And as such, they are tied to a specific purpose. So first of these clay tokens were used to mark transactions, to mark some barter exchanges. And that was their use, and they were only ever used for this purpose. No one would think to reuse them or put them to any kind of different uses. So that's where we started in terms of data. And then as we were moving along, we were becoming more and more I want to say sophisticated in how we were creating data. We're moving into what we characterize as the period of analog data. And a good example here is a census record that goes back to Hirschman et al. 1995 and their book, where we look at census as one of the first examples of how a more organized collection of data was taking place. And a difference, if we want to contrast it with the physical data, the difference in here is that the data, so what's recorded on paper, is separated from, or it's separate from the paper. So you can move that data, you can copy it, you can change it. It's not the same as the physical object. So we see some kind of a separation emerging in here. And some characteristics we can notice in here, this kind of analog data is recorded when needed, but it's rarely recorded. So it's recorded in the case of a census every 10 years, right? That's where the name comes from as well. And the changes are very difficult. So once the data is recorded in a census, then it's stored and it's created for and tied for very specific purposes for mostly state organizations knowing facts about their citizens. But that moves us along this evolution of data. And as we again fast forward a little bit closer, that's when we begin to talk about the kinds of data that perhaps we are in sort of widely conceived information systems most familiar with. And we begin to see what we term computerized data. And a good example in here could be transaction record, referring here to Wanden Weber, 1995. So transaction record is something that we used to record in early databases, and for example, also in relational databases. So whenever an organization, a company would have an order placed or sold an item, there would be a record of that created in a database. And we call this kind of data computerized because it's related, or at least it is stored on computational media early on, from tapes through databases to relational databases. There is an element of the computational medium in there. They are recorded at the point of transaction, and I think we can all agree they're recorded much faster than, for example, in the case of census. So whenever there is a transaction, they are recorded in there. Changes are not impossible to these records, but usually laborious, in the sense that you would need to have someone who has the ability to modify databases, know the language that's required to, for example, change the fields and change the database schema. But what we also see, interestingly enough, in here is that other systems can enable the reuse of this data. So we can take some of the existing records and, for example, analyze, and that's how we begin to do first analytics, analyze, for example, which store has more transactions than another one. So that was enabled largely by the ability of other systems to connect to this data. And this takes us further along to the most recent turn in if you like, the history of data. And that's where part of our argument comes in. And what we're saying is that there is something different about the kinds of digital data that we're observing right now. And an example in here I would like to refer to comes from our own work with Aleksi, where we looked at online behavioral traces, so trace data that are logged about or the activities of organizational actors in systems are logged whenever they click on something, whenever they view something. All that is just stored in a system. And when we were trying to understand and tease out what's different about this kind of data, we were trying to juxtapose it against these previous periods of data history. And I think it's relatively easy to see how these kinds of digital data are different from physical data, from clay tokens, how they are different from analog data. Also, I think we can make this argument quite persuasively. But I think that the real interesting detail comes into how we try to draw a distinction between computerized data and digital data, and how we work out what it really is new or different. And that's a question that I've personally been trying to answer for the last 10 years and try to really identify what is it that is different about this data. So we can say that there are some characteristics that are different. They are recorded whenever an activity takes place. They are very easy to edit in the sense of adding another column to the database schema, collecting another piece of data, and so on. And they are often collected for unspecified purposes and can be very easily reused and put to other uses. So the question here becomes, is this a good start for us to see that digital data are somewhat different from these previous categories, and whether this difference matters, right? And what is that is changing when we're looking at using and really immersing our world in digital data. So let me leave it as a question for all of us to think more about, because I don't think that we have all the answers in here. Is digital data really different? I think we can hypothesize that it is, but I think part of the work that we need to do going forward is to really unpack more and more and understand a much finer level of where these differences lie. And now I would like to move on from this historical perspective to give you a glimpse on to some of the findings that we have looking at all the papers we collected in our data studies bibliography. So this is a collection that Aleksi and I started a couple of years ago now, and we're running it now together also with Daisy Shu, who has joined us recently. And within this data studies bibliography, our goal was to really try to identify papers that reveal and say something about data as an object of study. And as we're building this collection, we thought that it would be really interesting to try to analyze what is that these papers are saying about data. What are the different perspectives that we can see revealed in here? So we started this analysis some time ago, and broadly speaking, there are three perspectives that these papers take on data. And these perspectives are, if you'd like, assumptions that the papers take, rather than necessarily this is how they view that data really is. So what I'm saying is that sometimes, of course, as researchers, we make certain assumptions so that we can do research, but we're aware that they may be just assumptions. So I wanted to spend some time just looking at what these assumptions or ways of studying data are. And the first group of papers that has that we have identified is the one that sees data as records. So researchers in here make these assumptions that data are, in a way, some kinds of records or inscriptions of real-world entities or events, and they are neutral inputs that say something about reality. And then again, this is not to say that the researchers in this vein just assume that or think that this is how data are, but that's the assumption they make so that they can present the arguments or give us the arguments that they would like to communicate in their papers. So in here, for example, we see data and the focus of data as, for example, through some of their characteristics. So many studies in here, for example, look at what makes a good data point. How can we know whether data is accurate or complete or consistent within a database? How do we make sure that data maintains stability across contexts? And what are the properties of data as records of something outside in the world? So if you'd like, the focus in here is more on understanding how data as these recorded, more perhaps inscriptions of reality, how they function within the systems. Another view that we identified is this view of data as representations. So in here, scholars focus much more on really perhaps the relationship between the data and the phenomena they stand for, and they say that's something interesting, right? That we need to really understand how data come to be to represent things in the world. So they look at the semantics or meanings of the data, how data are always interpretations of the world, how they depend on the context within which they are created, what's the user understanding that goes into creating a data point, what is the design intent, so what the data were created for, and so on. So in here, there's an understanding that data are always some kind of symbolic abstractions of phenomena that are shaped by, for example, modeling grammars, but also human cognition. So data modelers who create data, the way they think and understand the world, impact what kind of data is created, and also what they are meant to communicate. In the last group of papers we found in the bibliography, take the view that of data as artifacts. So they really want to understand how data come to be as things. And in here, the core view of what data are is that they are constructed, performative, and entities that are embedded in infrastructures, and that they co-constitute realities that they describe. So there is, if you'd like, the way I have recently come to understand it is that this last view looks at that data as entities in the world and the bidirectional relationship between these two. And in here, scholars often think about, for example, the syntactic, so the format-related aspects of data, together with semantics, so the meanings and the infrastructure. And they're looking at how data are mutable, how what they refer to, so the phenomena in the world may be unclear, and how these data are designed for what makes them performative. So this is really interesting because it gives us almost three different focal points of interest, three different points of view on what we can think of and how we can study data. And I think that for anyone who would like to get into this discipline, this is very interesting because it shows us what are the different lenses, if you'd like, through which we can look at this phenomenon. And now let's move on from this to what are and how we can define digital data. So having looked at these three perspectives, we attempted to define or offer a provisional definition of what digital data are. Myself, Aleksi, and Kaleidoscope in the introduction to our handbook that we'll mention later a little bit as well. So we tried to work out, now that we know how others have talked about data, and knowing that we want to argue there is something different about digital data, what is a provisional argument that we can offer? So we offer this provisional definition of digital data as records or of events and entities that can happen, or these events or entities can take place in the physical, digital, or artificial worlds that are encoded into a computational medium that also have, I would say, some, or at least some of the following characteristics: updatability, so the new data points arrive very fast; editability, so we can change the database schema and the format very easily; heterogeneity, so we can at the same time be recording voice, video, and text, for example, and storing even in the same database, which relates to structure, in the sense that we can be recording data in far less structured ways. Then we have granularity at a much higher granular level than in the past, and functional coupling, which is how tight the data are recorded to a specific purpose. So what we're arguing is that these digital data have, and that's a point that perhaps needs a little bit more working out as we collectively go forward, at least some of these characteristics. There's also another element to that I would like to add, and if we can move to the next slide, Aleksi. Something that we're trying to argue and understand now is look or zoom into the if you'd like, an understanding of digital data to see how is that we can really understand what is changing. So if we agree, or at least for now, with the previous characteristics that we, the 6 characteristics of digital data that we showed up on the screen, there is another way of analyzing digital data that we want to bring to this. And I want to talk you through an example. And Aleksi, if you can, thank you. An example that goes back to one of my own papers, where we argue that it's important or insightful to analyze different aspects of data, starting from their semantics, so the meaning of data. What are they intended to represent? And in that specific case, we look at an example of gender identity data as an example of personal data, and how a change of what is the meaning of gender in database systems changed what was recorded about data. We also talk about syntax, which is the structure of data, like schemas, values, and aggregation. And in that particular case, we talk about how the syntax, or if you'd like, the format in which the data was recorded. And here you can see on the screen the actual setup of the database that was created to reflect the change in how gender identity data was understood anew. So from a recording of what the organization used to do, which was legal sexes, zeros and ones, they moved into recording of 3 different tables with 11 potential different values in each. So that's a syntactic change. And something that I would also add to the paper now that it's not there now is another layer or another element of that, which is pragmatics, the intended purpose of data, what they will be used for. And in here, there's a screenshot from the text where I think now it's visible, where actually in this specific case, what ended up happening was that no one was using this data. So it was created for a purpose of allowing individuals to represent themselves and feel they are represented. And it was actually not created for any other use in the organization. They didn't want to run reports. They didn't want anyone to see this data. So the intended purpose of data, what they will be used for, is also an interesting aspect. Now, the argument that I would like to make in here is with digital data, we have far more flexibility, ease, and possibility of changing the semantics, syntax, and pragmatics of each data point than what we had with previous generations of data. So we can, as you can see in this case, change the syntax, change the semantics, change the pragmatics, and we end up with a very different data point. And that brings us to the last argument, which is this. And that's something that we talk about in the introduction to our handbook. What we say is that when we're dealing with digital data, and remember that the semantics, syntax, and pragmatics are just a way of trying to understand what's happening, that are trying to help us capture that we are changing something. So when we're dealing with digital data, when we're changing these different elements, what we end up with is this. Does anyone know what this is? If you do, raise your hand or nod so that I can see. This is a kaleidoscope. So I'm also wondering if this is going to work. I don't know if you know how a kaleidoscope works. Maybe you played with one when you were younger. I have one in here with me. It's really cool, very old school. So I'll see if this is going to work. I'm just going to put it in here. That's what you can see inside a kaleidoscope. Now, what happens when I turn it? You see what happens? The pattern changes, right? What you can see in there creates very, very different images. And that's what we're saying happens with digital data. And that is what we argue in the handbook. Aleksi? So what we say is that the characteristics of digital data make data like glass fragments in a kaleidoscope because they can always be recomposed to form a different rendering of the phenomenon. And this kaleidoscopic nature of data is not only about the perspectives we bring, but also about how data can refract what we're trying to capture. So they allow us to create specific versions of reality while obscuring, diminishing, or removing others. And I'll pause at this point, and I'll hold this argument in, if you'd like, in the air to think about, and I hope that it will bring some thoughts, and we can look into it later. But at this point, I will hand it back to Aleksi.
Thank you, Marta. That was a brilliant introduction to the complexities of data, and hopefully that illustrates that what I said in the first part, that we really strongly believe that data is much more complex phenomenon and than you may initially think. And to make sense of it, what we have been promoting or kind of helping to come together is what has come to known as data studies, which is to give you a provisional definition of data studies, is that research that takes data as its object of inquiry. Now, what this means in detail, I don't exactly know, but actually that's really good thing, because it means that it's an open, evolving thing instead of something that somebody would have put a closure already around it. And it's also an opportunity, especially for guys you like kind of the younger scholars, to join something that's being built and not something that's already kind of set in stone. And also, I think it's important that we don't, because what we have seen here is that data is very complex phenomenon. So it's kind of, I think it would be a mistake to try to put a premature closure on it, and that this is it. So just to give you a little bit more about what is data studies. So here are some provisional answers. Let me start what it's not. So data studies is not a theory. It's not a specific kind of way of studying data. It would be, of course, great. In some ways, it would be great if we could have one theory to rule them all. But what we have seen here is that I think the phenomenon, and the more I have studied data, the clearer it is that we can't kind of pin it down from just one angle. It's not a particular methodology. A lot of the studies what we have been doing, there have been a lot of qualitative studies, but there are also high quality design science studies, laboratory experiments, even quantitative studies. So in that sense, data studies is open to all kinds of methods. So, and I think that has been also because I'm a person who I don't do analytical modeling, but I do almost all other kinds of research. So I strongly believe in heterogeneity of methods that we approach this phenomenon. And it's not in some way standalone research program. So what is it? if you want me to describe somehow data studies, I would say that it's perhaps best described as an emerging narrative around the study of data, group of scholars with similar interests, series of loosely connected events, and more to come. TC already mentioned the SIG data that we have submitted a proposal under AIS. So we hopefully will have by the end of the year a special interest group that will be working with many other interest groups. For instance, SIG-DITE has been a sort of major inspiration and kind of how things should be done and can be done. So to provide a kind of lightweight infrastructure for people interested in the study of data to come together and learn from each other. I will talk briefly, I will give you a little bit more about why I think this kind of the data studies is needed. And that's the next question here. So, but why is data studies really needed? Well, the kind of the core of my answer is this, that because data is a quite complex phenomenon that is both technological entity, data is processed, or digital data is processed by computational systems. That means that it puts certain material and hard boundaries around what we can do with data. We can't kind of wish those away. But on the other hand, it's also semantic material. And unless data can be interpreted meaningfully, it cannot represent anything. It cannot perform its function to represent something unless it can be interpreted meaningfully. And interpretation meanings are always a human thing, must be always founded on human institutions, cultural conventions, and institutional orders. And then, of course, data is a matter of practice, just something zeros and ones sitting on a hard disk somewhere don't do anything. They have to be embedded in organizational practices and put in practice. And but you see, here we have three very different approaches in social sciences, like practice-based studies, semiotics, engineering, that we need to understand data. And I think the risk is that unless we bring these together, we risk being the proverbial group of blind men who touch the elephant from different parts and then kind of don't get the idea what it is. So that's the kind of the core why I think we need some kind of collective of data studies. Sometimes I use to make sense of data studies. This is another attempt, which is what I call the iceberg of data studies. So above the waterline is typically what we see from data, how we understand it as records, like kind of mapping back to Marta's slide, which can be taken as ready at hand facts, representations of things there. When I do my quantitative analysis, when I run my DID model, this is how I relate to data. They represent something there and I don't contemplate how they represent. I take them as facts and that's it. And this is implicitly assumed, for instance, if you use data analytics or quantitative analysis, which is perfectly fine for many purposes. But beneath the surface, where there are different aspects to for instance, we can look at data as representations, which then often the question is that how can we model more truthful data? And this typically maps to traditional conceptual modeling and data quality research, which are long-standing important research streams in information systems. However, and this is typically what I have sometimes called the standard view of data. However, like in Marta's slides we saw, data are also artifacts in our everyday environment. We actually we relate and we react to data. We react to data production. We are more and more conscious that our kind of activities generate all the time data. So then the questions become like, how is these data artifacts designed? What kind of innovation work we can create with data. Data it's the raw material or kind of the key resource for many innovations and services these days. what kind of semiotic analysis and what are the semiotics of how the data artifacts work. And even below this, there are people who I would say, that study what makes data possible, what makes it possible that something emerges as data for something. Looping, and this what might be called the conditions of possibility for something to appear as data. We have relational perspectives, we have data work, we have data infrastructures and infrastructuring. And one super interesting thing here is that it's really that, like, now we have a technology, generative AI, that turns potentially all the digital content that's sitting on our hard disk into potential training data. So this is what I called data studies. Is really the what's underneath the surface in that iceberg. And obviously, because it's an iceberg, we can have all kinds of metaphors and stories about icebergs. But my argument is that unless we understand what's beneath the surface, we may basically crash with it and sink, unless in our society, unless we really also look at what's underneath the surface. Now then the question, why can't we just study these different layers separately? Why can't we stay in our own silos? So what's the point of bringing these together? Well, I have learned, and this is basically what I'm working out, I have learned a lot from working across these boundaries. So I have, for instance, with Marta, we have worked with people who fall more into this traditional conceptual modeling and data quality research camp, and that has been incredibly eye-opening. And the same thing with the people who work with who more of a question that what allows something to appear as data. So definitely that helps us to sharpen our own thinking, get new ideas, and also if you want a sort of instrumental reason, it's in the interest of the whole community that when we get a paper that's written by a person who approaches data from a little bit different angle, we understand their angle, or they understand our angle when they get our paper to review, so that we don't shoot ourselves in the foot just because by rejecting a paper that approaches data from different angle because we don't understand it. And I think that's one thing. And then, of course, hopefully we can also provide practical advice and help the world, those who don't contemplate what's beneath the surface in the iceberg, to make better and more careful use of the data resources that they are going to use, because everybody becomes a data analyst in some ways these days. So this is, I think, my last slide. And just to give you a brief idea, I'm not going to talk through all of these, but there are lots of interesting opportunities related to data. And not every, of course, I don't say that every study needs to be about data or needs to have a data angle, but just to give you some connections. Data is closely related to innovation, not just in terms of data-driven innovation, data-based innovation, but also we have one paper where we argue that data itself can be, or data design can itself amount to innovation. If data is one of the most important resources in contemporary world, then you can see innovating new kinds of data as the material innovation for digital world. Data governance, basically who owns, who should own, how can we share, how can we maintain privacy? These issues are going to just be massive, because managing the corporate data resources and making sure that they can be used to their full potential contains massive problems, and they are not going to go anywhere. So that's a fairly safe bet. Data has considerable implications to data justice and fairness. If things are decided on the basis of data, what matters is in data, and regardless how the things are in the, so to speak, real life. When more and more things are run through AI and data, the parties will try to poison the data resources. This is already happening. Another interesting aspect is that because the data resources have become so massive, they already the energy consumption of data resources is starting to become a limiting factor. We have to think about the very, very physical resource use kind of related to data. Another and this is, I haven't seen a single study of this. I would like to do it myself, but I just put it out there if somebody can do this, is we typically tend to talk about that everything is being datafied. We talk about datafication as a sort of one-way movement, but I would like to read a study on de-datafication, how we can decide that something that has been datafied will not be datafied anymore. Is that even possible? I think that's very interesting, potentially very interesting topic. I don't know if it's possible or if it's happening anywhere. It's just a fascinating idea that can be studied, de-datafication of some aspects of the world. And many others, like we have quantum computing emerging. What is data there and so forth. So I'll stop here. We have, I think, talked about 1 hour. So, the last thing, what's happening in the data studies. So we already mentioned that we have the Data Studies Bibliography that I have posted in the chat, where we have collected a highly kind of carefully curated resource on high quality papers on data from key journals and conferences. We are maintaining a database of books on data and teaching cases. We have a blog with regular guest posts, and we have the Scholars at Data Studies mailing list, where we post. It's not very active, but that's actually the nice thing with the list, that you are not being spammed, but basically where we post about events around data. And we have our book that Marta already mentioned that just came out, and there are a couple of communications of the AIS panel reports that kind of talk about data studies that are also, I think those are probably also open access. And we have submitted the proposal for SIG data under the AIS. So a lot of things coming. So I think that with that note, thank you very much, and time for questions and answers.
Yeah, thank you so much for